Hi, in this video we will learn how to use OPC UA in LabVIEW. The contents in this video is short about what is OPC UA, and then we will show some examples. We will create an OPC UA server in LabVIEW from scratch, and we will also create two OPC UA clients. One client that writes to the OPC server and another client that reads values from the same server. Here is the software you need in this video. We need, of course, LabVIEW. In addition, we need to install LabVIEW DSC module or LabVIEW real-time module. Both these modules installs the OPC UA functions we need to use. You can install all the software from National Instruments from this location. In this video we will go through this example. In LabVIEW application 1 we will create an OPC UA server. In LabVIEW application number 2 we will create an OPC UA client which write to the OPC server we just create here. And then next, LabVIEW application number 3 will read from the OPC server the values we write in this application. So what is OPC UA? UA stands for Unified Architecture, which is the next generation of OPC. OPC UA is based on modern software network architecture, and you don't need DCOM, and you don't have these DCOM problems that you have with ordinary OPC. Here we see standard OPC or OPC Classic with the different specifications: OPC DA, direct access; OPC HDA, historical data access; and OPC alarm and events. These OPC specifications works on Windows only, while the OPC UA specification is a cross-platform OPC standard, and it works on all platforms from Windows, Linux, Mac, embedded systems, real-time systems, etc. So here we see a typical OPC Classic example where we need different OPC servers, while in OPC UI we have a simpler approach where we only need one server and one or more clients, because the server includes everything we need. And also, as we mentioned, in classic OPC, these DCOM problems makes it very difficult to configure the firewall and make sure the values goes from the server to the clients. While in OPC UA we don't have the same problem, because we don't need to use OPC DA and DCOM anymore. OPC UI uses the modern approach based on web services and XML and modern web protocols. So here we see another example, the classic OPC, which use DCOM, and it's for Windows only. So we have server, which is a Windows computer, and you could have one or more OPC clients, and all the clients is Windows based. While with OPC UA you could have an OPC UA server which is Linux based or an embedded system, and then you can have different clients which could be Linux, Windows, or an embedded system. Now we will see how we can create OPC UA servers and clients in LabVIEW. As mentioned earlier, we need either the LabVIEW DSC module or the LabVIEW real-time module in order to have the functions that we need to create servers and clients in LabVIEW. When you have installed one of these modules, this palette will be available in LabVIEW. So here we have functions for creating servers, and we have functions for creating clients. Here are the subpalettes for the server functionality, and here are the palette for the client functionality. Next, we will show how we can create an OPC UA server in LabVIEW. We will create this simple example, which is a simple OPC UA server in LabVIEW. First, we need to create the server like this. We need to add one or more folders, and we need to add one or more items. And then we can start the OPC UA server, and then we can just include a while loop and a stop button, and the program will loop until we will stop this button. So the server will run until we stop the button. When we stop the button, we stop the server and close the connection, and we show some simple error message if that's needed. So now we will create this example in LabVIEW. So let's go to LabVIEW. Here we have a blank block diagram in LabVIEW. We start finding the palette we need. Right click, data communication, and then here we have the OPC UA palette in LabVIEW. So here we have functions for creating the server. First we need is this create. We need to add a folder. We need to add one or more items. In this case, we just add one item. We need to start the server. And then we need to stop it when we are finished. And we need to close it like this. So next we could create a simple for loop here. A simple while loop like this, and then we start wiring these together. So just wire the error between the different VIs like this. Here on output, here we have the output of the create, so we just right click, create indicator, and here we have the reference, which we actually don't need, so we just remove this one because the reference need to go from this one to this one to this one to this one like this. And then here on the create we have server endpoint URL. We right click on this one, create an indicator. If we double click on it, we see it on the front panel like this. We add a folder name. You just right click on it, create. You can create a constant in this case and write the name of the folder. You can call the folder whatever you like. I just call it process data in this case. Next we want to add an item. So we find the proper input item, right click on it, create constant like this. You can just right click on it, visible items label, visible items label, to see what the different properties are inside this cluster. This is a description. Here we have the access level. Here we have the data type, and here we have the name of the item. So let's start with the name. In this case, we have some temperature data we want to store in the OPC server. Temperature. Data type. Typically, temperature values is double. Here, double. Access level, in this case, we both want to write and read values, so we set read and write. Description, we just type the temperature values, something like that. Then from output here, you can see the path, item path, so you just right click on it, create indicator like this, and you double click on it, and then you see it here on the front panel. They are empty because we haven't started the program yet. Next, we want to have a stop button, which you can use to stop our program. So find a stop button on the front panel. We use a stop button here, and we wire the stop button to the end terminal on the while loop, the loop condition, like this. Also, it's good to have a timer. We find this timer, simple timer. In this case, we can just set 1000 milliseconds. Then we are ready to go. So now we can save our code. OPC UA server. You can go to the front panel to test it. And now we have a server running. Yeah. So here we have this server URL we need to use when we later are going to create the clients. And here we have the item path. In this case, just temperature. Next, we want to create the OPC UA client in LabVIEW. This client should write to the OPC server we just made. So we recently made this OPC server in LabVIEW, and now we are going to make this application, which is an OPC UA client, which write data to the OPC server. The example looks like this. It's very similar to the server. So here we need to have the URL, which is the same as the server generated in the previous example. And here is the item path, which should also be the same as we had in the server example. Here we just use numeric control to write a temperature value like this. And then we have a stop button to stop the client. So let's create this example from scratch. So you find the LabVIEW OPC UA palette in LabVIEW. It's under data communication, OPC UA. And here is the server palette we used in the server example, and here are the OPC UA client functions we need to use in this example. So first we need to connect to the server. In our case, we need to write to the server, so we find the write function. When you want to stop the client, we need to disconnect from the server like this. In addition, we need a while loop. Here. So let's start to create the functionality on the front panel. We need the server URL. Then you can just use an ordinary string control like this. Make it a little bigger. Change the name. Server URL. And we need also this item path. So just copy this one. I call it item path. In addition, we need a stop button, a Boolean stop button, like this. In addition, we need to enter a temperature value. The temperature value could come from a sensor or a DAC device. In our case, we just use a numeric control like this, and we can call it temperature. Temperature value, like this. So that's the front panel. Let's go back to the block diagram and make the code finished. So connect. We need the server URL wired to the connect like this, and then the ref num from the connect needs to go into the loop and to the write function like this. Like this. And the item path needs to be connected to the write function like this. The same with the temperature value like this. Also need to set the data type here. It was on Boolean, so you need to change it to double like this. Next, we need to wire the stop button to the while loop like this, and the output reference here needs to go to disconnect like this, and then you can connect the wire, the output of the arrow cluster to the input here, and output goes to the input here. In addition, we need a timer. So we use the same timer as we did on the server, the wait. Set the same here. We use 1000 milliseconds. So now we are almost finished. In addition, on the connect, we need to add some security policy. So you right click on the security policy, create constant, and then we need to set this one. You can right click visible item label. This is the message mode, which is just known in this case. This is the security mode, which is in this case basic 256. It's okay. Now our function should be working properly, so you just save it. You call it OPC UA Client 1. Next, we will create a new client that's read the value which is saved to the server. Next, we want to create the OPC UA client which read values from the OPC UA server we created earlier. So first we created the OPC UA server, next the OPC UA client that writes data to the server, and next we want to create a new OPC UA client that reads the data from the server. So let's see how this LabVIEW application works. We have the same server endpoint and we have the same item path, and here instead of writing values we should read values in this numeric indicator. So let's create this program from scratch. So this OPC UA client will be almost identical to the previous one. You find the data communication palette, OPC UA palette, and the OPC UA client palette. You use the connect. Instead of write, we need to use the read block. We need to disconnect when we are finished, like this. We need a while loop, like this. We need a timer. Set the same value here, 100 milliseconds. And we need a stop button. So we go to the front panel and create a stop button, like this. We need the same server URL, so we use the string path, string control, like this. Change the name to server URL, and we also need an item path, like this. We change the name, item path, and in addition we should read the temperature value from the server, so we need a numeric indicator. Change the name to temperature data, like this, and then our front panel is finished. And let's go back to our block diagram and finish our code. So the server URL should be connected to the connect, like this. Temperature data should be connected to read value, like this. And we need to change the data type to double, like this. Stop button needs to be connected to the while loop, like this. And then the item path needs to be connected to the read function, like this. And then we connect the refnum from the connect to the refnum on read, and the output goes to disconnect, like this. As we did on previous client, we also set some security policy. So just right click, create constant, like this, and we use the default security policy. And then we should be finished with this one, like this. And here is the block diagram. So now we have created 3 applications in LabVIEW. Application number 1, OPC UA server, and then application number 2, which is an OPC UA client that writes to the OPC server, and then application number 3, which is also an OPC UA client that reads the value from the server. So let's try this in real life. Then we have these 3 applications. So let's start the server, and then we have the server URL generated by the server, and then we have the item path generated by the server. So we copy this information through the clients, like this. And then we can run the second program, the OPC UA Client 1. And this client is running, and then we can run the third program, the OPC UA Client number 2, and then this program should be able to read the value we write to the server in the first client. So let's try. Yeah, you see here the value. If we change the value here, the second client also are able to read the value we write to the server in this application. So that was a simple example how we can use OPC UA in LabVIEW. In this example, we will not going to create it in LabVIEW. We will just show how it works. So here, in this case, we have an OPC server similar to the previous one, and then we have an OPC UA client that writes data to the server, and then we have the second client here that reads the data from the server. But this client is a little bit more sophisticated. It only reads value from the server when the data on the server is updated. So we use a subscriber module, and this application is a much better approach for real applications. So that's all for today. Thank you.